intro. Are we good on the mic? Yeah, there we go. I hear it now. Cool. And I don't quite see my slides. If we could switch to this guy, that'd be great. So yeah, so like Nia said, my name's Will. I'm a product manager at Neo4j. I work on the AI innovation team. So we spend a lot of effort making sure that Neo4j remains the best graph database for AI use cases as well, and so that's what my team focuses on. You can find the slides, graphstuff.com/CG meetup, context graph meetup, or the QR code there. So there's been a lot of great discussion around context graphs. This really bubbled up and resurfaced, I think, after Foundation Capital put out this post about, context graphs are a $1 trillion opportunity for AI. There's a really good context graph paper from a couple of years ago. And there's been a lot of discussion about what's needed for context graphs, the challenges, and a lot of good discussion around it. I think what's common in all of the discussion around the context graph topic is it's all about this idea of the missing why, right? So that if we have, I don't know, an agent, recommends making a credit approval decision, we need to understand, why? What is all the data that goes into that decision? And this isn't just about AI agents, right? Fundamentally, a context graph is a knowledge graph that contains all of the information necessary to make decisions throughout the organization, right? And so we may keep these in a audit log, which shows, okay, this is the, line by line, we rejected this transaction. But why? What are the specific pieces of the, policy that went into this? This may be stored across lots of different systems that we need to sort of combine together and query across in one knowledge graph. And that, to me, is fundamentally what this idea of context graph is all about. So let's look at maybe an example in the financial services world. How many people here work in financial services? I'm just curious. A few. Okay, not many. Yeah, this is San Francisco, so makes sense. So if we think of okay, what's the data model that we might need for a context graph for the financial services world? Well, we're going to have people, we're going to have people that have accounts at our bank. There's going to be transactions. These are the events, right? So transactions are what happened. Entities, the people, the organization. These are the things. And then the context, the why, we're modeling these as decisions, policies, these sorts of things. So let's take a look at an example. This is online. You can run this context graph demo over Vercel.app. We'll take a look at it. So this is a demo app that I put together because I saw all this great discussion about context graph this and context graph that, and we could do this, we could do that. That'd be really neat. And I'm yeah, okay, cool. Let's try to take something that looks a little bit real and see what we can come up with here. So this is the data model. We have this data loaded in Neo4j, very similar to the slide I just showed, but a bit more complex, right? So our decisions, they apply a policy, but decisions also serve as a precedent, right? So we have relationships that connect our decision nodes as well, and we also have some additional information like alerts, support tickets, this sort of thing. So just a little bit richer data model. And so we can think of this as, let me zoom in as much as I can here. So think of this as what, I don't know, an analyst at a bank might use this sort of tool to respond to customer requests, that sort of thing. So this is a context graph agent. So we're saying, hey, we have a credit limit request from our customer, Jessica Norris. She's requesting a $25,000 limit. And we can see here, if we inspect the details of our agent, Our agent has lots of tools. These are all tools that we've defined how to interact with our context graph, and of course it has a system prompt. You are a helpful agent that knows a lot about financial services and so on. And then we have the tool calls, right? So tool calls are the way that an agent interacts with and understands its environment. And we can see here all the tool calls that this agent makes to fetch the data, to fetch the context that it needs to make this recommendation. And we render all the pieces of that in a graph, right? So we can kind of see the different people, decisions, policies that were implemented here. We can like double click and traverse out through the graph to get more information for our analyst. We can also look through the causal chains of decisions and so on that led up to this. And ultimately we get a recommendation from the agent. In this case, the recommendation is conditional approval and says, hey, do you want to record this decision? Great, yes. Record this in the context graph, and this will update our graph, adding another decision node that will then serve as precedent and so on going forward. So again, you can feel free to play around with this online. The code is open source. There's a blog post that explains how it works as well. Now, if we look at what's actually going on here, how is the agent tracing this decision history to make this recommendation for it? How is it using this context graph? Well, the first thing it does is it searches for the customer, right? And then looking for the context around that customer by traversing the graph and finds, oh, well, this customer had a previous fraud flag. We can then use hybrid search, so combined vector and graph search to find the most relevant precedents and ultimately make our recommendation. This idea of hybrid search, combining graph and vector, by the way, I think is really important and really powerful. Neo4j has tooling called graph data science, which allows us to run graph algorithms like centralities, PageRanks, or here we're talking about graph embeddings, in this case the FastRP algorithm, which is a way of generating and embedding not just on like the content of text, right? So if you're familiar with text embeddings and maybe storing those as vectors and doing vector similarity search, right? That helps us to find, in this case, decisions and policies that textually, like semantically, are similar. But what about the structure? And that's where things like graph embeddings come in. We can actually look at the structure of a account's relationship to the way it maybe interacts with transactions, other accounts, these sorts of things, the fraud patterns that we see. These can also be used to generate embeddings, and then we can use similar vector search functionality that we're familiar with to find the most relevant data for our context. So there's a little bit more about what's going on in the context graph demo, some of the other graph algorithms that are used, some of the tools, sort of a resource for later there. So that's all fine and good. Like we saw like a nice agent chat. We saw how it can help us make decisions and apply policies. Like that's great, but how do we actually build one of those, right? And this is one of the bigger challenges of making use of a context graph is how to actually capture these reasoning traces. And so at Neo4j, we've built a Neo4j agent memory Python package that allows you to add graph-based agent memory to your agent, and we have integrations with pretty much any agent framework. But I want to talk about kind of how we think of the relationship between memory and a context graph. So Neo4j agent memory, this is an open source Python package that you can install and leverage. Again, lots of different framework integrations. We'll talk a bit about entity extraction, because I think this is an important piece of the agent memory package. So there are sort of three high-level abstractions of the type of memory that we're working with here, and I think they're all needed for the context graph, right? So going back to this slide, like context graphs need short-term memory, long-term memory, and this reasoning or decision traces, right? Like the decision traces and the auditing, like, okay, that's obvious why we need that. It may be less obvious why we need short-term and long-term memory as well. So short-term memory, this is conversation, session state, like working memory, think of it like this. When we're using the Neo4j agent memory package and we save a message, this kicks off a background entity extraction job that's kind of like moving us from short-term to long-term memory. And so we're looking for all of the entities, all of the connections between the entities, the facts. We're extracting that from unstructured message data and loading that into the graph. Now, there are several other agent memory systems that have this concept of entity extraction to construct the graph. One thing that I realized, or we realized when we were building this, it's really important, is not just using LLM-based entity extraction. This is very, very slow and very expensive to send every message to the LLM and say, hey, what are the entities? How are they connected? And so instead, we have this pipeline approach where we start with some of the more probabilistic statistical methods like named entity recognition, the things that are available in like the Spacey Python package if you're familiar with that. Then we use things like Gliner2, which is a local model that is a pretty small model that we can run on CPU for specifically fine-tuned for extraction and entity extraction and also relationship extraction, which is quite nice. Then we only need to fall back to the LLM. So that's built into this package. I think that was quite important for handling large amounts of conversations. So we talked about this entity extraction process. One thing that's important in entity extraction, in addition to like not just relying on the LLMs to do that for cost and efficiency, but also the data model that we use for entity extraction is really important. It's really important that the memory that we are saving to the graph is relevant for our domain, right? Like if we're financial services, we should be making sure that we're saving financial services related data and not unrelated things like, I don't know, where someone's kid went on vacation, or I don't know, whatever's in there that might not be relevant, right? And so by default, we use this POL, people, organization, location, event, plus object, so POL plus O model. If you're familiar with POL, it's used a lot in crime investigations and this sort of thing. So this is the default model that we use though. So you have the ability to apply your own domain model and those are the things that are then extracted out. Like this I think is also really important for agent memory. And the third piece here is the reasoning memory abstraction. I think reasoning memory is one of the more important pieces for building context graphs. And I think it's this piece that we actually don't see a lot of support for in a lot of the AI agent memory frameworks that are out there. When we're talking about reasoning memory, this is, you may hear terms like procedural memory is another one that's used here. So you can think of this as kind of like procedural memory with a little bit more to it. So this is recording like the tool call traces that we make. These reasoning decisions are stored in the graph as well, right? So short-term, long-term, reasoning memory. These are the APIs that we have available in Neo4j agent memory for not just constructing your context graph, but also like searching it, finding the most relevant context, assembling that for your agent. So when you combine these all together, short-term, long-term, reasoning memory, this is all one connected graph, right? So short-term memory are conversations, entities extracted from those conversations, and then reasoning traces, tool call, reasoning steps. Those are connected to the messages and the entities that are retrieved for the context, right? So now that we have our memory in one graph system, we can query across data from all these systems. Here's what this looks like. This is an example of hitting the three different types, right? Storing a short-term conversation, searching long-term memory, and then recording a reasoning trace. So there's another example that I'm going to touch on just quickly here. So this is another demo app that we built. It's online. The code is open source. How many people are familiar with Lenny's podcast? It's like a popular tech product kind of podcast. So we took the transcripts from Lenny's podcast, ran that through the Neo4j agent memory as if it were like a agent conversation, and sort of constructed a context graph from that. And so we can do things like ask, what are all the locations mentioned? So in the Brian Chesky episode, Brian Chesky is a co-founder of Airbnb, and so we can, we automatically geocode and then enrich the locations that are extracted, right? So Bolinas is mentioned. I don't know, Brian Chesky owns property there. I don't know. I didn't listen to the episode. But then it's enriched by data from Wikipedia, right? And RISD, that's the Rhode Island School of Design, where Brian Chesky went to school, right? And so I guess what I'm just trying to point out here is there are other types of information in the graph as well that we extract, not just textual data, right? Like here we're working with geospatial data, and this concept of enrichment, I think is also really important. Cool, so I'll skip maybe going through more examples of that to talk about just kind of the architecture of the Lenny's memory example. We go through this entity extraction to context graph construction, and then we're able to create agents that are able to interact with that context graph. One thing that might be interesting, let's take a look. So this Lenny's memory app, so this is running publicly. We can see all the previous questions that folks have asked. This is what folks are asking publicly out there, right? And what we do is we record and write back to the graph the reasoning memory from everyone's interaction with this agent. So I have this running in Neo4j Aura. This is Neo4j's cloud service. So if I go, I think it's this one. And if we open up Neo4j browser, so this is the query workbench for Neo4j. And so we can see here, we can see the entities that were extracted in the episode and kind of query that way. But I want to let's look at our reasoning traces that we've recorded. So here's a reasoning trace that has 2 steps. So each step is a tool call, and we're recording the tool call result. We're recording the number of tokens used, the response, and so on. And this becomes the basis for the reasoning memory and understanding the traces that our agent is taking. Cool. So anyway, a little look at what that looks like in the graph. We've been doing some integrations with lots of the different agent frameworks. This is a look at some of the cloud vendors with agent frameworks that we've built integrations with the Neo4j agent memory package with. And these agent frameworks, so like Google ADK, AWS Strands, or Microsoft Agent Framework, they all have their own sort of memory abstractions. And so we wire those up to Neo4j agent memory, and then we publish a specific integration for those packages and make sure we support their models and running on things like Vertex if we're looking at ADK or Bedrock if we're talking about AWS. Also some other functionality in some of the releases like MCP, OpenTelemetry support opaque as well if anyone's using that. Another interesting demo app, I just want to leave this as a resource. There's an agent swarm version of this financial services demo. So if you want to see what it looks like to have a bunch of different agents with different personas, maybe we have a anti-money laundering agent, a compliance agent, a customer service agent, and they all have a shared memory layer. So I thought it was really interesting to see what does this look like if we give, not just a single agent, but across, all of our agents are both contributing to and understanding, fetching context from a shared Neo4j agent memory layer. So that one's quite interesting if you want to check that out. Just a link of some resources. How many folks are registered for Nodes AI in April? Okay, that is like 10%. That is not nearly enough. Everyone needs to scan the QR code, register for this right now. Nodes AI, so Nodes is Neo4j's online conference, the Neo4j Online Developer Education Summit. We do this in the fall, but we've just now started an AI version of this. So this is really fun. We're going to do workshops leading up to this as well. So definitely register for Nodes AI. We'll be giving lots of talks about context graphs and lots of folks from the community sharing what they're working on as well. Cool, so that's all that I have. You can get the slides with the QR code or that link. We're going to save questions for the end. All the speakers, plus Emil, who's in the audience somewhere, is going to join us for a panel discussion at the end. So we'll save questions for that. So that's it for me. Thank you very much.
Thank you so much, Will.